Hello everybody. Today we will solve some PTOE questions. These are all traffic engineering related questions. We will do 25 such questions today, and we will also make another series. In the next part, we will solve another 25 questions. Okay, so total to 50 questions we will solve on traffic engineering related problems. So this will also help in your PE preparation, where you have that transport. If transportation is in your depth exam, it will also help there. But this is mainly traffic engineering related questions for PTOE. Okay. So having said that, let's start. The first question is saying on a freeway with a density of traffic flow of 60 vehicles per mile and a space mean speed 40 miles per hour, what is the average headway? So its given density is 60 vehicles per mile. This is the density. The space mean speed, that is S, is 40 miles per hour. Okay. So what is the flow? So first we need to find out what is flow. Flow is equal to S times D, right? The space mean speed times density is equal to flow, right? This is a very critical equation, very important equation. You all should, I hope you know it. So flow equal to space times density, right? So here, so first they want us to find out what is the average headway. So average headway is, what is average headway? What is the unit of average headway? Average headway, it's like how much ahead a car is from another car, right? So it's like how much seconds per vehicle. That is a unit of average headway. So basically average headway and flow is reciprocal to each other, right? So flow equals 1 by average headway. Basically flow equals 1 by headway, right? So that's why we are first finding flow, and then we will the reciprocal of that flow will be average headway. Okay. So speed is 40 miles per hour, density is 60 vehicle per miles. So we are getting 2400 vehicle per hour. That is the flow that we got. Now we need to find out what is the average headway. Let's represent it as H. So H, I said, equals 1 by V, right? We need to find out how much, and you see the unit is given in seconds per vehicle. But here we got it at vehicle per hour. So it should be 3600 divided by 2400. So this will give us 3 by 2, which will be seconds per vehicle. This is 1.5 seconds per vehicle. So this is the correct answer. Hope you guys understood how we solved it. So the next problem is using ASHTO calculation method. What is the stopping side distance for a road with a design speed of 60 miles per hour and level grades? So it's saying the design speed is, let's say V, which is the design speed. It is 60 miles per hour, and we need to find out what is stopping side distance. Okay. So what is the stopping side distance? Like how? What is the formula here? Stopping side distance. So first, we already know, right? Stopping side distance. What is stopping side distance? First part is how much time the driver takes for the to realize and start the action, right? Of the brake. Like first the driver needs to put the brake, right? So that is the first part of this equation. The first term is that one, which is V into T, and T is the perception time, right? So I'm just writing the formula here, which we have converted this 1.47 into V times dt. So because we will put V in miles per hour, and you will get SSD in feet. Okay, that's why we have multiplied it with 1.47. But all these equations you will already get, right? So you don't need to memorize it. You will have all this with you. Okay, but still I'm just, for some clarification, I'm giving you some sort of explanation. So this is a part where the driver realizes that it needs to pull the brake, right? And the second part is the time taken by the driver to actually stop, right? So that is 1.075 times v square by a. So according to ASHTO, the this perception time is 2.5 seconds, and with this deceleration, basically it needs to stop, right? This is 11.2 feet per second square. Okay, so after that, if you let's say put in the values, what will be the solution? 1.47, v is 60, t is 2.5, plus 1.075, v is 60 squared, divided by 11.2. So if you solve this, you will get it as like 566 feet. I already solved this before. So you will get it as 570 feet. So basically, if you round it off, 566 feet. Generally, you should put 570 feet, right? It is closer to this number. So this is the solution of the second problem. So let's go with the third problem. So when timing pedestrian intervals for traffic control signals, what pedestrian walking speed should normally be used? Basically, what is a pedestrian walking speed? So it is as clearly it said that it is 3.5 feet per second. Basically, we need to remember this. Okay, pedestrian walking speed 3.5 feet per second. So a short-term stationary temporary traffic control zones occupies a location for. So how much? What will be the answer? It will be more than 1 hour within a single daylight period. So that is short-term stationary. So basically, you have like what are the types? I hope you, because you also need to remember all the types, because in this problem it came as short-term stationary, but there are many types like long-term stationary, which is long-term stationary is more than 3 days, right? That is greater than 3 days. Then intermediate, I think it's intermediate, something like that, which is 1 to 3 days. Then it's short-term stationary, right? Then it is uh, then it is mobile, right? Which is like less than 1 hour, like 15, 20, 15, 30 minutes is mobile. So you need to remember that four or five which you have here. You need to remember all the types of temporary traffic control zones, right? Anything can come. Okay, so for this problem, this is short term stationary. It will be 1 hour to 12, like single daylight periods, 12 hours. So let's go to the next problem. Which of the following is a possible example of a system interchange? What is system interchange? Like interchange, there are like two types of interchange. Okay, so one is system interchange, one is service interchange. So one is system interchange and one is service interchange. So system interchange, what it does is, no, it's for system interchange you have like signals, like, and for service interchange, like there will be no signals. Like from one freeway to another freeway, you will find no signals. Okay, so sorry, I just said the system interchange you will find no signals, and service interchange, like basically no signals. And signals, I mean, is like you will find an intersection here. For service interchange you will find intersections, like at grade intersections. Okay, and for system interchange you won't find any such intersections. Basically, you can easily say, let's say system interchange, this answer will be clover leaf. You see, if this is a freeway and this is a freeway, this cars will directly, oh, I'm sorry, let me draw it here. This is a freeway and this cars will directly go to this, and this is another freeway, right? So there will be no, basically no such at grade intersection, and these cars will directly go and go like here, like this here. Okay, so you see there is no such basically signals or intersections, right? So similarly, it's like full clover leaf, right? So this will go and this will go like this, and this will go and this will, basically all the four directions. This is like this, right? So this is a full clover leaf. So for full clover leaf, you will find this is system interchange, no add grade intersections. But for the other three, diamond, partial cloverleaf, and single PUI, these are examples of service interchange. Okay, so let's move to the next question. Which type of signs may be excluded from the minimum maintained retroreflectivity guidelines contained in the US Manual of basically MUTCD? All right. So what signs you can be excluded from the retroreflectivity guidelines? So speed limit signs, parking signs, street name signs, school signs. This will be parking signs. Okay. So parking signs, you can exclude parking signs from minimum retroreflectivity guidelines in the MUTCD. So these are direct questions. You need to know these answers. Okay, for PTOE. So what is the present worth of a safety improvement benefit of $5,000 that will occur 5 years in the future at an interest rate of 4%? If an interest rate of 4% is used. Okay. So future benefit is $5,000 that will occur 5 years in the future. What is the present worth? So what is the present worth? So you will get this equation. Still, I just wrote it down. You will find this. They will give you a formula sheet, right? What is the present worth of something where you will get the benefit, where in the future the benefit is $5,000 5 years later. Okay, that will be the benefit. So what is the present worth today? So you see, if you put 5,000 here and I is 0.4% 5 years here, then what will be the answer here? You have to just find that. So this will be around like this 4109.6. So this will be like $4110, which we have here. This is the correct answer. So let's move to the next question. Using the standard dual ring phase numbering convention, what two phases could be displayed simultaneously? So if you see the how the dual phase system works, this standard dual phase ring, this is 1, this is 2, this phase is 3, this phase is 4, right? This phase, this is left turn, okay? This phase is 5, this phase is 6, right? This phase is 7, this phase is 8. Okay, these are the phases. So how will you draw the dual ring phase? So 1, 2, okay. There will be a barrier here. 3, then 4, a barrier here. 5, 6, 7, 8. Okay. So barrier, a barrier. Okay. And this is a ring. This is a ring by itself, and this is the second ring. Okay. So you see, this is one ring, and this is the another ring, and this is barrier. So basically, what it means, when we move from this, when we go from the all way all this, when we move from here to the next one, all the phases has to be addressed. Only then you can move this barrier and come to the next lot. Okay. So and one one phase from this ring can always be with another phase of the other ring. Like you can like one can be with 5 or one can be with 6. This is what it means. 2 can be with 5 or 2 can be with 6. Okay. Now let's see what are the options given. So 1 and 5 can occur together. 1 from this ring and 5 from the other ring. Yeah, 1 and 5 can be together. This is fine. I think this should be the answer because he said, let's see the other one. 6 and 8. You see, 6 is in this one, and you have to cross the barrier, and 8 cannot be from here. So 6 has to go with 1 or 2. So this phase is not correct. 1 and 2. 1 and 2 cannot be together. So 1 has to be from the ring 1, and the other phase has to be from ring 2. Okay, so this is also not correct. 2 and 7. 2 is from here. 7 is you have to cross the barrier and here. So that's not correct. 2 has to be with 5 or 6. Right? So this is also not correct. So the answer is 1 and 5. So let's move to the next problem. The manual on uniform traffic control devices states that when speed limit within a speed zone is posted, it should be within 5 miles per hour of what? Okay. The speed limit should be within 5 miles per hour of 85th percentile speed. It's given the average speed of the traffic, the 15th percentile, and the design speed. So it has to be within 85th percentile speed because the majority of traffic, let's say uh, 70% of the traffic is within this 80th percentile and 90th percentile. Like 5 miles, like sorry, but like 5 miles, like within, let's say this is 85th percentile, whatever its speed is, and if you go 5 mile per hour less than 85th percentile and 5 mile per hour greater than 80th percentile, this range, maximum traffic falls under this range around 70%, and the other 30, the 15% will be less than that, and the other 15% will be greater than that. So the police wants to actually only focus on only 15%, this 15%. So that's why we uh, speed limit has to be within posted within 5 miles per hour of 85th percentile. Okay. The US manual on uniform traffic control devices states that specifies that the diamond symbol on signs is to be exclusively used. This diamond symbol, okay, it is exclusively used for HOV lanes. You always have to remember it. The diamond symbol is always used for high occupancy vehicle lanes. It always has to go with that. So it's given reversible lanes, electronic toll collection lanes, high occupancy vehicle lanes, two-way left turn lanes. So answer is high occupancy lanes. Next question, by US federal law, every urbanized area over what population size must have an ongoing transportation planning process. So that should be always greater than 50,000. If it's greater than 50,000, you will have a transportation planning process. Okay, transportation planning process. And if it is greater than 200,000, you also need to remember this figure. If it is greater than 200,000, then it will have transportation management areas. Transportation, these two numbers are very important. Management areas. Okay, you see they have also given this number because some people will not exactly remember if it is transportation planning process or transportation management areas. To confuse those people, they gave the 200,000 also. Okay. So next question is, a roadside slope is considered recoverable if it is equal to or flatter than. This is a road. What should be the roadside slope? So recoverable is if it is equal to or flatter than 1 vertical is to 4 horizontal. Okay, that is recoverable. And it is also remembered, you also need to remember this: 1 vertical and 4 horizontal. Between this and this, 3 horizontal, 1 vertical is to 3 horizontal, this is non-recoverable. And in my PTOE exam, it came like, what is a critical slope? But if it is less than 1 vertical is to 3 horizontal, that is critical. Okay. So you also have to remember all this one. If it is equal or flatter than 1 vertical is to 4 horizontal, that is flatter. But if it is between these two, There is non-recoverable. If it is less than 1 vertical is to 3 horizontal, then it is critical. Also, you need to remember desired. What is the desired one? This four you need to remember, right? If it is 1 vertical, 6 horizontal. Okay, so like this or flatter basically. So this is desired. 1 vertical is to 6 horizontal if it's flatter, uh, or flatter, and you know what is recoverable, non-recoverable, and what is critical. All right. So the next problem, the US manual on the MUTCD specifies that warning and guide signs used for temporary traffic control in incident management situations may have a black legend with what colors background. So for incident management, you always have to use fluorescent pink. So for signs in the color of the signs is very important for PTOE exam. Color, like it's not just this incident management. You also have to do like regulatory warning signs. So all those colors, guide signs, basically anything can come from colors. Okay, so it's very important. It's a good idea to memorize the colors for signs. So the next question, a road safety audit. What does a road safety audit do? A check of compliance with design standards? No, that is the work of a designer. A structured process by a team of qualified professionals focused solely safety. Correct. This is the right answer. The network screening process based on crash records? No, that is again the work of engineers, or maybe this is a more work of a transportation agency. They will do the screening first. A method for redesigning major reconstruct project plans? Not at all. Okay, let's move to the next question. What is a maximum super elevation rate that ASHTO recommends for locations where snow and ice conditions prevail? So maximum super elevation is for snow and ice condition is 8%. Okay, but for plain conditions, plain, it will be 12%. Okay, but many agencies actually also do prefer 6%. Many agencies prefer 6%, but please do not write that, because ASHTO says recommendations for locations where snow and ice, ASHTO says it's 8% for snow and ice, right? But also please remember this one, which is 12% for plain conditions. Okay, this is important. So the next question is, the US manual on uniform traffic control indicates that the traffic signal walking person indication should be displayed for a minimum of. So the walking person indication that has to be displayed for a minimum of 7 seconds. You need to know this. Okay. On a Next question, on a road with a design speed of 50 miles per hour and level grades, what is the ASTO minimum stopping side distance? Similar sort of problem, stopping side distance 1.047 VT plus 1.075 V square by A. You will all these formulas in your formula sheet. Okay. So as I said before, this is for the time it takes for the driver to actually start the brakes, pull the brakes, and this is the actual time it takes to stop the car, right? So this is 1.047. V is given as 50 miles per hour. T, according to ASTO, it is 2.5 seconds plus 1.075 times V is again 50 square divided by A. ASTO has given it as 11.2 feet per second square. Okay, this is a deceleration. So if you do the calculation, you will get it as 423.7 feet, which is near to 425 feet. Okay, so this is the answer. The next question is a crash modification factor that is less than 1. So if the crash modification factor is less than 1, then the crashes will reduce, right? If the crash modification factor is greater than 1, then the crashes will increase, right? That is how you have that Bayesian model, right? So if the crash modification factor is less than 1, the crashes will likely be reduced. This is the answer. On a freeway, next question, on a freeway with a flow rate of 3000 vehicles per hour and a space mean speed of 60 miles per hour, what is the density of the traffic flow? So the density is, it's given the flow rate v equals 3000 vehicle per hour. Space mean speed is given as 60 miles per hour. What is the density? We know v equals s times d, right? So d equals 3000 vehicles per hour divided by 60 miles per hour. So this will give us vehicles per miles. So this is easy. So this is 50 vehicles per mile. So the next question, if an incident blocks one of the three freeway lanes, let's say this is freeway, this is one lane, this is second lane, and this is three lane. Three lanes are there. Okay. The likely if an incident blocks one of the three freeway lanes, so let's say there is an incident and this lane gets blocked. Okay, you cannot go. Then the likely capacity reduction due to the incident. So what is in normal case? What is the capacity? What is the flow? What is the flow of a freeway lane? So that is around 2,400 vehicles per mile, right? In a freeway, I'm talking about. Okay, so nearly around 2,200 to 2,400, like that, 2,500, somewhere right there. Let's consider 2,400 vehicle per mile. But let's say when there is an incident at one of the lane, the capacity or the flow becomes zero immediately, right? Now, what happens is even the next lanes, the other lanes, the capacity reduces to like around 800, 1800. So when there is like a complete, this lane will get completely it gets blocked. The other two lanes also, the capacity also gets reduced to around like 1800 vehicle per miles. Okay, so it's like little bit variable. It actually becomes like 1800 vehicle per mile, somewhere from there to 2400 vehicle per miles. Okay, so let's consider 1800 vehicle per miles. That is a usual state at that point of time. So what will be the, so basically for two lanes it will be how much capacity? 1800 times 2, it is 3600 vehicle per miles. That much it can kind of fulfill. And initially, how much was the actual capacity? It was 2400 times 3, which is around 7200 vehicle per miles. So if you see what is the actual reduction, you will see 7200 minus 3600 divided by 7200. This will give you around 50% into 100%. If you do, it will give you around 50%. This is nearly 51%. So obviously you are will not get the exact answer, right? Because you are assuming this as 200, 2400. It can be a little bit different, like 2250 to 2400, anything. So this is also generally it's like 1800, 1900, something like that, right? In that range, because basically it means when you when this lane cannot function anymore, the other two lanes the capacity will reduce. So that it what it means, it cannot address the demand of 2400 vehicles anymore, right? So it drastically reduces. So so yeah, so that will be the answer. Basically, actually you need to remember these things, right? You need to remember if there are three lanes, one lane gets blocked, what will be the capacity likely reduction due to this incident. You should remember it's 51%. But since I just wanted to show you the background why it's around that number. Okay, so next question, what are the colors most commonly used for regulatory signs? This is, you need to remember it, white, black and red. Okay, red is for those uh, what is that called? Generally red is used for prohibition, right? And white black, speed signs and all those are coming in white, right? Red is, let's say, the stop sign is red, right? So for prohibition, those kind of signs, regulatory signs, you use red. So let's move to the next question. What is the minimum vertical clearance for a sign installed above a sidewalk? Not a secondary sign, because the main primary sign, what will be it? Let's say this is the road, this is the curb here, this is a curb, let's say, and the sidewalk is here. This is a sidewalk, okay, and there is a sign here. So what is the height of this one? So for a city or for this urban area, this should be 7 feet. And since it's saying sidewalk, so we will assume this is in an urban area, so that should be 7 feet. But you should remember, if it is in a rural area, all this is very important. Let me tell you that it's not just you remember this 7 feet, you need to know the entire story. I am telling you, for many problems like that. It's not that only for this you will remember, okay, this is a sign in an urban area, what is should be the height, minimum vertical clearance 7 feet. No. It has to be like, if it's an urban area, that height should be 5 feet. Okay? And if you put a secondary sign below it, let's say you put a secondary sign, so that will be 1 feet less than, if it is 7 feet, then 1 feet less than this. If it is 5 feet, then it is 1 feet less than 5 feet. If you put a secondary sign, what will be the vertical clearance when you put a secondary sign? So that will be, at that time it will be 5 minus 1, this will be 7 minus 1. So that time it will be vertical clearance is 6 feet, and this time it will be 4 feet vertical clearance if we put a secondary sign. So these 4 points you need to remember. One is urban, one is rural, and one is urban plus secondary sign, and urban and rural plus secondary sign. Okay, let me just write it. Urban, you need to remember 7, urban plus secondary sign 1 feet less 6, rural, that is 5 feet, rural plus secondary sign, that is 4 feet. All the four numbers you need to remember in this case. Okay, so let's move to the next problem. We will do two more problems up till 25 in this video. The next video we will do another 25 problems for this PTOE. So using the following travel time study data, what is the average travel speed for the 2.75 mile route? Okay, what is the average travel speed? Okay, so you see travel time data, the travel times are given. So basically this is like a space means speed, basically, right? What is average travel speed? You see they have given you the travel time. These are not spot speeds that they have given you. When they have given you spot speeds, then you can find the time mean speed, right? This is very important. Two other concepts: what is time mean speed, and what is space mean speed. Okay, so since they have given you the travel time, okay, so basically that means they want you to find the space mean speed. Although they haven't mentioned it, they just said average travel speed. So anyway, so if they have given you the travel time, first you need to convert this into seconds, right? This is 340 seconds. This is 370. This is 420 seconds. This is 300 seconds. This is 440 seconds. This is 330 seconds. Okay, now the average of this, all these terms, the average will be 366 seconds. Okay, so what will be the average travel speed? Average travel speed, that will be this mile, 2.75 miles divided by 366 seconds, but they wanted it in miles per hour, so you have to multiply it with 3600 to make it into an hour, right? and here you will get it as 27 miles per hour. So basically you see here you are doing the average. So that, like, the when you do the average of this travel time, that's when you, if it, that will be space mean speed. Okay, I hope you know the difference between time mean speed and space mean speed. In case you do not know, please investigate the time to understand this too. This is also very important concepts. I am giving a little bit demo of what it is. Space mean speed, let's say this is a car here and it traveled all the way up till here. You find what is the travel time it took. There is another car. These are called floating cars. Okay, and you found what is, again this same car, it went back and it again traveled the entire corridor to see what's the time it took to cover the length. Okay, and all these times the distance is always the same. From here it starts from here and it ends here. The distance is always the same. So that distance divided by all the time it took, right? So average of all the time when it does, you get that as space mean speed. And what is time mean speed? Time mean speed is simple. Let's say all the cars are, you see three four cars passing one point, and you have a radar gun. With the radar gun you found what is the speed of each of the cars. Just average the speeds, you will get time mean speed. Okay, so space mean speed is like within this space you are finding, it's more holistic kind of nature, like within this space, and how much is the space mean speed. You are defining the space, right? That's why you're doing d by this. And this is spots mean speed. At one spot, what will the time mean speed? That is time mean speed. All right. So next question is 18 crashes occurred on a 3.2-mile section of two-lane roads during a 2-year period. The AADT on the road is given. AADT is given as 13,000 vehicle per day. All right, everyday average annual daily traffic, that is given as 13,000. What is the crash rate? And crash rate is, how much is the crash rate? You see, they have given you a section, 3.2 mile section. So when they give you a 3.2 mile section, that is, you have to crash rate. You have to do it per 100 million vehicles, right? So the number of crashes they have given as 80 number of crashes. 80 number of crashes per how many vehicles? AADT. Third, when you have 13,000 vehicles, you have 18 crashes. 2-year period is given. So 2 year, this number of vehicles now. 2 times 13,000, right? Oh, sorry. And what is the length it's given? And you see, one more you have to do is 13,000 is for each day. So how many vehicles for 365? Because 18 crashes occurred for, not like, for during a 2-year period 18,000 crashes occurred, right? So basically 365 times 1 13,000 times 2. So this number of vehicles you found, like in that time, this amount of vehicles were there. It was the 18 crashes occurred, and the exposed cars was 365 times 13,000 times 2. And 3.2 mile is a section, so you have to do 3.2 miles, right? Vehicle miles. And times, you will do per 100 million vehicles. 100 times 10 to the power 6. First you will say, you will define out of how many vehicle miles 18 crashes occurred, and then you will do times 100 million vehicle miles. You need to find out how many crashes will occur if there are 100 million vehicle miles. Then what? How many crashes will occur? That is the crash rate. So if you do this thing, you will find the answer as 59 crashes per 100 million vehicles. So that will be 59 crashes. So the next problem is, this is the last problem for today. By using daily and monthly expansion factors, future raw traffic count can be adjusted to estimate AADT. if the April ADT average daily traffic for a road is 3078 and the ADT for the road is 3419, what is the April expansion factor? So the April expansion factor, so that will be the ADT for the road and ADT and April ADT divided by April ADT. So ADT for the road is 3419 and April ADT is 3078. This gives us 1.11. This is the answer. So hope you find this helpful for your preparation in PTOE, even for your PE exam, and even if you are just preparing traffic engineering for any exam, for your engineering exam, like your BS or MS engineering exam or BTech, MTech, whatever. So I hope these problems are helpful to you guys. We will solve another set and we will build it on. Okay, from here. So yeah, hope you guys find this helpful. If you feel that this is beneficial to you, please like and subscribe to our channel. All right. So see you in the next video. Thank you.